Hello everybody, thanks for stopping by the shop for another Screwy Tuesday. I think I got a nice video for you this time. We got a few different things. One, if you look just over my shoulder, if you remember not too long ago in one of my videos when I did the shop shuffle, I mentioned that I was still trying to figure out a method for my grinders. Well, this is kind of a la Keith Fenner. If you watch Keith Fenner's welding area, you can see how he has his grinders lined up. Well, mine are not all matching grinders, but I've solved the problem. I can go over, take a grinder off the rack, the cord's not all tangled up. It's working very well. I'll show you, we'll break and I'll show you a couple things that I did, but nothing great here. The other two things we're going to see in today's video is Saturday, I got to go on a couple of shop tours. Myself, Carl, and my good buddy Flea Market Dave. And we went over about a half an hour drive. A couple of friends, Brian and Alex, each have their own shops. They're kind of like in an industrial area, like an incubator space. Really, really nice. We had probably a couple, 2-3 hours of, walking the shops and talking about all sorts of things. Now I took a very, very short video, 8 minutes, I think, as I walked between the two shops. Little discussion going on, very jiggly, very poor. And we had spent a lot of time there, and at the end I decided I wanted to film real quick, and this is what you get, a real quick film. So that's in today's video. And then secondly, it's a follow-up to Modifications Part 2, which was another Screwy Tuesday where we visited with Carl in his shop, and we looked at the oiling system that he was redoing on his mill. And I think you'll enjoy this. It's really a recap of the work that he has done on it, along with some other bonus little tidbits of information I think you'll really enjoy. So with that, I'm going to stop the camera for a second, walk you over to what I did here, and then we'll be off on a couple of visits. Again, thanks for stopping by. If you like what you see, subscribe. Help this channel grow. I really appreciate it. So we have just a little handheld here to show you of how I constructed the rack there. So I've got some flat bar, 1/2 inch by 1/8 inch flat bar that I bent, and it's on a 1 inch by 1 inch 1/8 inch angle iron. And we'll take you over a little handheld walk and get you ready for the shop tour. But anyway, just wanted to show you how I bent the flat bar. This is a bender that I built some time ago. I'm using a 3/4 drive socket as one of my mandrels. Basically, whoops, I got it backwards here. I got to move you. Basically, loaded, found a spot that worked well, and then pulled on the bender and made my bends. So that was really a lot of fun. And as you can see, probably over there, I had various clamps and things out here doing the welding. It was a very enjoyable project and really solved a problem that I was having. I was hanging all of those grinders on the side of this cart, and every time you went to grab one, all the cords were tangled. So really happy with that. And with that said, let's shoot over to Carl's, and then we'll follow up with the shop tour at the end.
Good morning, gentlemen. We're back at Carl's shop and looking at the small milling machine project. I've been working for several months on adding a lubrication system that would lubricate the ways and the lead screw. That job is pretty well finished, not quite, but I'm going to take a little bit of time and give you an overall view of the mill and show you some of the finished lubrication system. Let's start at this milling machine. Don't know much about it. I bought it surplus. It was damaged. The motor drive unit, this is a typical import mill with a 8 by 30 inch table. The motor unit up here was smashed. The motor had looked like somebody had driven into it with a forklift and broke everything. I happen to have this particular J-head sitting around that mounts to a flat plate, and I also had this Bridgeport Model E shaping head, and a little head scratching and a little bit of flame cutting, and I had adapters so that I could put the J-head in the front and the shaping head in the back, and I just love this particular combination. Right now it is set up to calibrate the travel. We'll look at that in a little more detail in a bit. You can see here I have the test indicator for the X-Travel, and I'll show you what this indicator is doing because we have to level those. We're going to move from here and go around, and we're going to look at a little bit of detail on the lubrication system. So we'll be right back as we set up for that. This is a continuation of Screwy Tuesday's Modifications Part 2, which was filmed about 3 months ago, and you can go back and look at it if you're interested in the history of this. But the tubing coming out of the oil manifold is complete. So let's run through this real quick. This line right here is the pressure line coming from the hand pump, distributes oil through the junction block, through each of these 5 meter units, and then the oil flows up into various parts of the knee. One of the points of interest is this particular line, which has to be flexible as the saddle moves to and from the operator. In the original mill, this was covered with a long type extension spring. And I thought, well, that's a good idea, and I think I'll make one of those. In fact, I'll end up making 4 of them. And a little bit later, I'll show you how to make these long springs. So again, just to review, this line takes oil up into the saddle. This line takes oil down to the lower part of the knee columnway. Let's see, this one right here goes to the gib, and this one up here goes to the upper surface of the knee columnway. If we can get Chuck to pan down, we'll look at the knee lead screw.
There we go.
And the interesting thing is the lubricator. So here is it's a big chunk of aluminum turned to fit on the lead screw. It is removable. There's a screw here. I can take this off if I need to get to full travel of the knee down. But what's interesting is it's got a little lid, and whoops, it opens up, and you can probably just see there are felts in here. And in this particular one, there are 4 felts. And the one that you see here is fit into the V of the lead screw. The idea is that this one is really a cleaning felt and lubricating, and then there's a second one down there that completes the lubrication. So oil is wiped right into the V of the lead screw. So whenever I go to use this, I pull on the pump on the other side, which we'll show you in a bit, squirt a little oil on this, close the door, and we're off and running. Now I made boxes like this for all 3 lead screws, and a little bit later I'll show you how I cut these felts and a little drawing of how they're arranged in here so that we get good lubrication on the screw. Okay, we're going on over to the other side. Now a little dark back here in the corner, so we got the flashlight out. In the previous video I showed you the new pump, and here's the 2 discharge ports, and again I'm feeding a distribution block. 3 meter units go to the knee, and 2 go up to the saddle. One of these is the saddle way lubes, and the other is for the table lead screw. I had to think a minute on that. And again, you can see the springs, the coil springs that go around these. A little bit of protection. so that as they move, they don't crimp or something like that. Okay, we're going to go back around to the front of the mill for just a bit. Okay, adding the Bridgeport heads to this mill is, of course, not the only modification that I did. Very early, I added these two GB42 travadials. I like travadials. I tend to be happier with them than I do with DROs. It's far easier for me to watch this little red hand come right around, and I know exactly where I am, and I'm not trying to count numbers. And I make fewer mistakes on travadials than I do on DROs. The one mistake that a travadial will make, and it's very easy to do, is you will miss by one full revolution, so you can be out 100 thousandths. I typically will do layouts on a lot of my work just to make sure that on either DROs or travadials, I know where I'm at. So I'll have a little X. It doesn't need to be any closer than 10 or 15 thousandths, but there'll be a pencil mark or a scribe mark or something, and I tend to work to layouts. An interesting project was designing this. This is based on Bridgeport style bars for particularly for the saddle travel. Of course, the table travel is against here. But this is an interesting welding and layout and general design problem. Also, getting this accurately, this has to be parallel with the travel of the saddle very closely for it to read accurately. So right now I'm set up to calibrate the travadials. The first thing, of course, they have to be parallel. They can't be tilted this way or this way, and that's these two little pins, and you can see this indicator is set up so I can indicate this, and there are screws down here that tilt it like this. Once you have the travadial leveled, then you can calibrate it for its travel, and that's done by this bar up here, which has two pins with flats, and these have been ground to a couple of tenths. I didn't do this. A friend of mine did that work for me. And so basically, you indicate this surface, you travel over here, which is 6 inches, and if the travadial does not read exactly 6 inches, then you tilt it up or down like this. The contact wheel between the travadial and the table has a very slightly crowned surface, and this allows for the final adjustment for the travel. These things are reasonably accurate, and they are dependable, and again, I really like them. So that's why travadials on this. The big mill has DROs. I move from one to the other. I can do a bolt hole circle on one, and it'll match a bolt hole circle on this one. So I'm happy with that. Now, Chuck, can we see this right here? I think we can.
Let's move it a little closer here. There we go. Okay.
Well, one thing went wrong on this project. Oh, first of all, I got to tell you a little bit about this thing. This particular lubrication project ran far longer and far more money, and I made far more mistakes than I ever anticipated I would. But it's been worth it. One British wit said, "I do this kind of stuff for fun, and the longer it takes me, the more fun I have." Well, I'm not quite that cheerful about taking a whole lot of time. But it was a fun project, and it's been worthwhile. One of the things is now I can pull on that handle, and I come up here, and there is, that didn't show, this did. I don't know if you can see it on the camera, but there is definitely a film of oil on that. One of the problems that I knew about midway in this project was that there are too many oil passages in the knee, in the saddle. And I knew that it was only going to be a partially successful conversion. And as near as I can tell, I am oiling this surface, this one, and the sloping surface of these dovetails well. I'm also getting the gib and the back sloping surface on the table. I am not getting much lubrication here yet. I don't know if it just needs to be pumped up or if there's just simply too much resistance to oil flow in this, and I may never adequately oil this. I may have to continue just wiping oil in that, and I will live with that. The thing that frustrates me is that everything, when you take machine tool apart, bag and tag, you guys all know that, and I did, one part escaped me, and that's the plate that holds the wiper in place, and if that doesn't show up after a while, I'll just simply have to make one. we can't see this. Let's see. Oh, I know. We got two more things. We're going to show you this, and hang on while we take a look at the hand wheels. The little handles, they stick out in my walking space. My shop is a little tighter than I like. You know, I built as big as I could, and everybody does. I decided that I would invent folding handles, and they have been extremely successful. Pull a little knob, handle folds right up. Pull it like that. And these have been on the mill for maybe 10 years or something like that. You can see there's a slight bend in this. It got hit at one time by something. Doesn't seem to matter. Very, very successful addition to the mill. Show you one more thing on it. So Chuck, if you'll go over here and we'll look at the... This is something that you'll never see on another import mill. This is a power feed. Custom built by a guy who I only knew as Pete. He's passed away now, and I can't say much more. He had a similar mill, wanted a power feed, and at first he thought he would go into a manufacture and sale of these. And he later thought, no, I don't want the responsibility, a liability in case somebody gets hurt on a milling machine and some lawyer gets excited about it. So he never sold these power feeds. He gave me this one. It has a Granger worm drive motor for reduction. It is a little bit like the servo units in that there is something you move in order to engage the drive motor with the lead screw. In Pete's design, you simply, oops, is it going to pull? Oops, something wrong. Oh, there it is. You simply pull the handle out. Pull the handle in like this, and pull. There we are. Pull it out, and now it's driving on the power feed. There's no power to it. When I took this off, the electric cord was, the insulation had gone bad, and I haven't replaced it yet. I don't use power feed very much. Most of my projects are small, and I tend to hand feed all the time. It's there, nice addition to the mill, and I wanted to show you this very, very nice, well-designed, well-built power feed unit. I think that's it for the milling machine. I want to show you a little bit more about the lead screw oilers, and then the coil spring. So we're going to go over to another part of the shop and set up and look at those. Well, I should have made a slightly bigger drawing. I recognized that as soon as I taped it up here, and thought, well, I'll ask Chuck if we can view in close enough to see this. This is a cross-section view of one of those little lubrication boxes that I made for the lead screw. So here's the lead screw, and let's see, this is the OD and the OD, and this is the ID and the ID. I probably didn't draw it right, but that's okay. Here are the felts. So there are two, remember these are cross-section, these are donut shaped. There are two of them that are 1/4 inch felt and one out of 1/8 inch felt. The 1/8 inch felt is designed to fit right in the root of the thread, and so it has to be flexible enough to deflect by the lead of the lead screw. And the purpose of these is oil reservoirs, but also is to position this, hold it in place so it doesn't travel this way, but it is able to flex just enough to follow the groove. And so that's the design, the interior design of my lead screw lubricators. And again, they have an oil port that comes in somewhere, dumps oil into here through the meter unit, and so these will be kept fairly full of oil. And so these clean the OD, and this kind of cleans and lubricates the ID of the interior thread. And I hope this is successful. Originally, that mill did not have lubrication on lead screws. The only thing you could do would be to reach up in there with an oil gun and kind of squirt and hope that the oil landed on the screw and got distributed through the nut. So we'll see. Okay. This is the setup for making those long coil springs that protected the lubrication tubing on the mill. This is a copy of the Diacro spring winder. Not built in cast iron like theirs was. That's a monster machine for spring winding. It's actually designed for making pretty bigger springs compared to what I do. This is made out of MDF, and critical wear points are just simply covered with sheet iron. This design was done by a gentleman, a member of the New England Model Engineering Society by the name of Frank. He provided me with drawings. He also asked me not to disclose the drawings. He would like to publish them. He gave me permission to show the finished unit, and so that's what I'm doing. And let's go through this. We're going to start off, of course, here's the wire, and here's the mandrel, and I'm driving it right now with a drill because I've got a long one to make. This is the usual handle. This is the tension unit, and it's got a cam clamp, and so that you can quickly detension and retension the wire. The diacro is a little bit different than any other spring winder in that the coiling of the spring, particularly for compression springs, is controlled by the distance that the mandrel block turns. This sets the helix angle. And so I added this little micrometer, which is overkill. Ordinarily, this little thing just simply pivots. I thought it would be a problem to control the actual amount of lead. It's not. So this clamp obviously is aftermarket, and it is designed to hold very small mandrels. This particular clamp setup, which is over here, is really designed for mandrels that are 1/4 inch diameter or bigger. Even 1/4 inch is a little small for this particular machine. And so I'm using here a mandrel that is 964 drill rod, and it just simply does not support very well in this particular setup. So I'm ready. We are going to watch the wire. The wire goes over this guide block. I'm going to do 2 or 3 turns with no lead, and then I am going to turn it to the helix angle, and away we go. Almost out of wire, so we're going to do a couple of closing turns. There it is, and we will detension that so it doesn't go sproing too badly. We are going to cut this here and keep your hand out of the way, and it goes sproing. And there's the mandrel, and there's a short length of spring. I think you can see that the lead is not consistent. That's primarily because of I can control the lead partly by how hard I pull on this. This is not really self-feeding, but there is long coil spring, nice setup, far too big for the kind of springs I wind. I thought about making a smaller, a little more user-friendly version, but this does everything I need, and I'm happy with it. Want to point out one last detail, and that is these knobs. I used 2 of these. Some of you guys will recognize these as knobs that are on some of the Delta woodworking machines, and in a future video I'll show you how I took one of their knobs and made a pattern and then cast these knobs for this machine. Next I'm going to show you just a little bit of the spring winding lab, spring winding shop. We're reset for that. About the same time I was building that diacro spring winder, I came around a corner at the local flea market, and lo and behold, this spring calibration or testing unit was sitting there. Guy wanted $10, including the force gauge. And I go, well, I can pay that kind of money. And maybe a couple of months later, I went into our local industrial surplus vendor, and this particular one was sitting there. This piece and this, I can't remember. I've swapped pieces back and forth over here. Oh yeah, this belongs with this, and this somehow were together, which I don't remember. This was below that, that's what it was. Never mind. What I have here is a calibration for springs. I can see the deflection of the spring and the change in force. So you just simply write it down, and do a little bit of calculation, and I can tell you exactly the spring rate of this particular spring, which is being tested right here. So not terribly important. I think this is just a bit more of fun. I have used it a couple of times just because I needed to replicate a spring, and so I was able to get fairly close to the specification using the Dacro winder. This particular one has only one purpose. Actually has two purposes. First of all, it used pieces that were left over from everything else. But there are two ways of dealing with compression springs. Well, actually, with compression springs. One is you can, after they're finished, they should be stress relieved by putting them in an oven and baking them at, I forget, 600 degrees or something like that for an hour. Don't take those numbers too literally. You can also solid set them. You can put the spring in here and just simply go shunk like this and squeeze them down until they are fully compressed. That does tend to increase the stress in the spring, but my springs are very low duty. They are not used dynamically, and so that doesn't particularly matter. What it does is as I said, solid setting, it takes all of the possible change in length and compresses them, and at that point their length is set, and they will typically not change much over the rest of their life. Again, not used dynamically. If you have a high-duty setup, you want to properly strain relieve your springs. Okay, one more detail, and I'll let you guys go. We're going to go over here. Okay, this is a setup showing how I cut the felt wipers. I remember I said they're shaped in donuts, and here's a, I don't have any of the felts left. They all went into the machine, but this is what they look like. This particular one is 3/1000 paper, a little harder to cut than felt. I use the specially built inside-outside cutters. Here is the outside, and there's the inside cutter. Oops, Chuck says I got to get up here. And they are held on a mandrel like this, so they are concentric. It goes in the drill chuck, and we are going to cut all the way. There it is. Very, very nice method for cutting fabric, felt, paper, gasket cutting, anything like that. The principle is basically what a lot of guys know as a wad cutter. This particular style can be used either rotating in the drill press or as a punch. The block is, of course, ingrained wood, and this is simply made out of some 1x4 vertical grain, not vertical, but clear pine. And it's been used for a whole bunch of cuts. And whenever it gets too scabbed up, I just simply put it in the chop saw and saw a fresh face on it and go back to work. So there you have it. I guess we ought to, another time we'll show you the drill press. So, but we're running out of time, and I want to show you one other thing before we quit. Okay, we're back in the what I call the fab shop. This is woodworking, welding, foundry, dirty, repair, anything that doesn't get done in the machine shop. This has been the worst shop over the last 20 years. It has been piled full of trash, and I finally says enough's enough. I was tripping over things, and I'm afraid that, you know, if I fall now, I'm old enough that I might not, you know, I don't want to break a knee or something. So this gets cleaned out, and new tables and a new central workbench that's going to go right about here. But rather than having it just sitting on the sawhorses, and these legs are tripping hazards. I mean, they just cost me all kinds of problems. So this is going to get a proper woodworking bench made out of solid steel, well, tubing. So this is the setup. I've got the first of the frames squared up, ready to tack weld. There'll be a second frame identical to this. And of course they turn up this way to form the table. I have a maple top that will sit on top of that there. The only other thing, I borrowed these clamps from Chuck, not for making the frame, but when I go to stand these up and weld the two of them together with their stretchers, this is real handy because it's easy to clamp them square. So that's what I'm working on today, and when this shop is finally all cleaned up and set, we'll do a shop tour. Thanks a lot, guys. We'll see you again sometime.
Okay, if you guys want a little shop tour, it's going to be handheld, so hang on. This is a friend that I know, his hobby shop, and it's a beauty. So I asked him if I could film, and he said yes. So got the barbecue just in case. So we'll take a tour this way. A little shop area, clean, refrigerator. He's got an office out front there. Got a vertical mill. Got a nice 10EE. Got a work table here. Double bank Craftsman. Here he's got parts for the 10EE that he's painting. A little paint rack there. It's welders. Got a nice setup table right there. Got a lathe, CNC lathe, CNC mill, nice plasma table, vehicle rack, and he added a mezzanine inside. Real nice hobby shop. Thought I'd share this with you guys so you could wish you had space like this. There's a glass beater. I forget what's back over there. Plasma. Arbor press there. So just a quick tour. I know everybody likes seeing somebody else's shop. Okay, continuing on the shop tour, we're at my friend's second friend, two buddies next to each other, and we're over into the second shop. Yeah, for double the fun. So
we got a CNC lathe. I think this is a cleanup and resell project. An old FANUC control that came from one of the lasers. I need to put this on eBay and find a home for it. We have a three-phase Variac. Always handy when you want variable three-phase voltage. Little A Sierra F1 Swiss-made watchmaker's mill. This is one of my favorites. And the F2, its bigger brother.
it's an F2 decal.
F2 A Sierra. So this is
A
A Sierra, that's
A
the
Sierra.
next size up, A Sierra. We need to restore that. Decal FP3 with the jig boring head and the universal table. That's a machine that I bought 15 years ago and have yet to clean up or put back into operation. Really feel bad letting her sit and not run. This is a very unusual piece, Shaublin 53. It's the biggest of the Shaublin mill lineup and quite possibly the rarest.
And this whole
40
ram.
taper. This has a broken gear, so I'm not going to do
Okay.
too much of this, but it rotates this way and
Yeah.
it telescopes out.
Yeah.
And the telescoping is the part that's broken.
Ah.
When you telescope it out further, you can
The head will knuckle.
loosen this knuckle and swivel it.
Uh-huh.
So you can make it into a vertical. This also comes off and you could put different attachments on. Not nearly as elegant as a decal, but approaching that concept.
Nice.
My tiny little Japanese air compressor and a bigger but less adorable compressor.
And we got this baby.
The Dual Zephyr monstrous bandsaw. This was probably the most overdone little bandsaw I could think of.
Yeah, all hydraulically controlled, right? Everything.
Yeah, all these controls are hydraulic valves. The table in and out, post up down, table tilt, it's all hydraulic.
Yeah. Then we got
Another one of my favorite machines, the
Yes.
one bed 10EE Monarch.
That's a beauty. Nice, beautiful long bed. Got taper attachment on it.
Yeah, the taper attachment's still an ongoing project. I think
yeah.
I'll end up putting a different taper attachment.
Yeah.
And there's pieces of a hard inch.
There
I'm
we
trying
go.
to determine the best way to get rid of some wear on the cross slide, whether we're gonna turkite it or regrind it or re-scrape it, who knows?
Yeah.
Another laser.
Ah.
This needs to go on Craigslist for someone to have fun with. Tensile tester, small 2-axis CNC lathe.
This little Enco lathe sitting off to the side here.
Yep.
Yep.
Electrodynamic shaker, the giant loudspeaker.
Oh, that.
Yeah, also useful for annoying the neighbors. Make things shake.
Oh, wow.
So
this is a Monarch long bed, right?
Yep, just like the other one, except this was a tracer machine. This had the air gauge tracer. Stylus is here. You would put a template in the template holder in the back. And instead of a swiveling compound like a tool room lathe, it has a fixed compound and the hydraulic slide for the tracer. I'm hoping to restore this someday. Remove this
I think one of these are on Craigslist right now.
off of a larger machine, or part of a larger
Machine, yeah. Just
And this has a much bigger
Oh,
than
yeah.
normal tailstock quill with bearings that basically
Yeah.
make a dead center into a live center.
yeah.
Don't know what I'm going to do with that. Might turn it into a traditional tailstock. It'll be an unusually large quill. We've got some miniature turbine engines.
Turbine engines.
Tensile tester. A CMM, a 3D printer that I'm trying to resurrect. Turbine driven generator,
Generator.
400 hertz, that has a solar T62. And kind of a random mix of decal parts, truck parts, decal accessories, Monarch accessories, welding positioners. There's an ACR F3 in pieces that I started restoring and never finished. Diesel driven generator, and there's the rest of the hard inch.
That's a beauty too.
Yeah, I got this machine thinking it's in extremely good shape, and it is, except for
For the slide there, yeah. Cool. Thank you.